Hello everyone and welcome to today PLC programming tutorial. We will use this software logo soft comfort for programming our PLCs, and especially we will use the ladder logic diagram. There are UDA, power block or sequence and other programming method also, but here we will just only focus on ladder logic diagram. So before jumping to the ladder logic diagram, we will see which example we are gonna use it. Uh, Here you can see here layout or diagram of PLC logo Comfort R230, and we are using to start and stop control for a three-phase asynchronous motor. We are going to use this uh, DOL starter, direct online motor starter. This is one of the most basic and most important program for anyone starting with the PLC. Once you master this, you can build more advanced motor control systems. But before we jump into the software, let's talk about the task and the hardware component we are going to simulate. Here you can see we are in a PLC. We have an emergency start button. It stops the operations when we press it. Stop button, there push button, and start push button. We are also here thermal overload relay. When there's overcurrent, it's gonna stop the motor from the operation. And here we will connect this also as input. We have a contactor. Here we have two circuit breakers. But this PLC inputs and outputs both are 230, 210. Alternating current, so we do not need any relays or transistors to operate this. Yep. If you see here on the inputs, we have three inputs from here in the form of buttons. One is the emergency push button, stop push button, and uh, start push button. We will also take input or take thermal overload relay as input. Yep. Uh, The thermal relay is a protection device. It is normally close contacts, so we will use 95, 96 because it should be on the close contacts. Uh, yes, under normal operation, current passes through, but if the motor draws too much current, the relay opens the contacts and shut down the motor. It must be manually reset. It's very important that you have to reset it manually. We have only one output, that is the contactor. The contactor is electrically controlled switch that can take the motor to the three-phase supply. You can see here that the electrical supply goes to contactor to the motor. Yeah, the PLC output, you can see here this Q1, Q2 energize the contactor coil, and when the coil is energized, the contactor pulls and it powers the motor. So this is all we have to simulate in our PLC Comfort Logo software. Now let's jump to the programming. Here you can see the interface, menus, and instruction sets. But as I told you, we will going to use ladder logic diagrams. So here you can, if you see here, you can press directly, it will goes to the ladder logic diagram, or we can go from the file menu to the file and then to the ladder logic diagram. New, we have functional block diagram, ladder, UDF, but we will use the ladder logic diagram. Here we have the interface menu. Here are all the instructions menu. Yeah, uh, as we know that we will use four inputs to the PLC. So first, let's start with the start button. On the left side, go to the mm, instruction. tree, it's called basically the instruction tree. This, if you see on the left side of this, and on the constants, you can see the make contact. Take that and place it here in the programming interface. Now in the programming interface, you can see here we have first input IN, I2, I3, but in the if you see in the diagram, my start button, you can see here it's connected to I3. So we should go to I3, click here I3, and if I click double click again, so you can see here I will just write a comment. For example, this is my uh, start push button. Sorry, I write button. It should be my start push button. This is very important in the simulation. So when we go to the in the parameter, we have selected my input comment, write what you name it, and then in simulation we have switch momentary push button make, momentary push button break. But here we have to select uh, make because we have connected the start or wire the star push button in the normally open. So we have to click on the momentary push button make and click OK. So we have done our first instruction is input. Now take another make input, click it here in the programming interface. For example, now I go with I1. For example, it's my emergency start button, emergency stop button. You can see here our emergency button. We have connected the emergency stop button in the normally close. So we wired it as a normally close, so it should be break my contact when I want to press this button. So it should be momentary push button break. This is very important. You have to check about these things. Normally close and normally open when the push buttons start and stop an emergency button. Because the stop button and the emergency buttons normally operate in the close, normally close. Okay. If you go back to the diagram, and if I see that my stop button, you can this is my emergency stop button, and I2 is my red stop push button. So I take another one, click in I2, comment. So parameter I should go to I2. Now I change write in comments. For example, this is my stop push button. In the simulation, it will also be momentary pushback break because it should break my contact or the because it's also normally closed in the operation. Okay, let me give a little bit space here so it's visible. Okay, now thermal overload relay, as we have already talked, it should be always normally closed new operation. So and it's also our input. So we should take another one from the make contact, click it here, and there should be either 4 IPUR input comment. I can, for example, I should write thermal relay. In a thermal overload relay, and there should be also my break, push button break. Okay, so these were all our inputs. Now, after placing all our inputs, we will place our output. So in the same instructions, we should go to the relay coil, take this, click it here. As we know that our contactor, if you see in the diagram, our contactor is connected to the Q1, wired to the Q1 of our PLC, and I2 of our contactor to the Q1. So our output will be Q1. For example, I can write also here in the comments that this is my output Q1 contactor. Mm, okay. Now, if you see, we have one, two, three, four, five, four inputs and one output. So we have placed all our components here. So now let's make it connected or wire it. You can see I can take this one also connect or I can click F5 to connect it. So from here I can drag it to here, then here. This should be all now connected in the series, or we also call it in logic, but we will discuss this later. But now you can see that I have connected all in the series. If I simulate this one, so if you see here with the PLC near, they have written simulation. So is IM, so I click on that simulation. So the simulation run. Now here on the bottom, you can see my simulation. If you see here IN, I2, or IPER, they are in the normally closed contact, and I have put that on the break, momentary break. So when I press this in, it should break my contacts or break my all wiring, electricity through the wire. Only I3 is normally open momentary, so it will basically make my contact. So this is very important. Normally open makes my contact, or normally close breaks the contact. So what does basically means the contact? A normally closed contact means it conducts its in its normal state and opens when pressed. And the same with the normally open, it does not conduct, means no electricity pass through in its normal state. So if I when I press it, so it become closed and it conducts the electricity pass it. But here, if we see here, if I click on the push button, it energizes my contactor. You can see a light switch on, but when I release it, it goes switch off. Why? Because of the push button. It doesn't hold my circuit. So here it comes the holding circuit, like in the manual contactor. Uh, and the manual contactor, we connect this to 13 and 14. 13 and 14, why? To make it a holding circuit. So when I press it, it latches my circuit and the electricity continuously pass. But here we don't use this, so we have to hold here making in the program. How we can do this? I stop my simulation. So we have to, a solution for this is OR gate or parallel feedback. It's very easy. We take this output as a feedback, here is input. And or we can make a logic gate between start push button and contactor. In OR logic, anyone, if we press push button or the contactor is on, still our contactor will be energized. So here I take go back to the contacts. Now when I click here the contact, I want the feedback of my QN. I can search my output here. You can see here this is my output relay. So you can see here in the comment it will come automatically what I have named it before. Now to wire it here, you can see here and then here. Sometimes we try to wire it here. Wait, I do it again. So basically, it should not wire here on the menu incomplete. It only is on makes on the contacts you see here, and here also. Okay, so now when I simulate this one, so the Q1 contactor will give a feedback path in parallel with the start button. So for example, I click here. So no, the contactor is not yet energized. So when I press on the push button and I release it, the start push button, the contactor is still energized. You can see the light is still on because you can see here that this Q1 contactor gives another path to the contactor to be energized. The motor will keep running because the feedback keeps energize this. But how to break this contact? I will break, for example, I press a stop button. So it will stop my motor. You can see here. Start again, press, so it start here. I can also simulate here, press here the button. For example, I press an emergency button. You can see here. Okay, yes. But here, now our emergency push button, we have to make a little bit changes in that. So if you see our diagram, the emergency button is when I press it, it stops the contact and then I have to release it manually. I didn't mention this before because not to confuse with all the things. But here, when I press it, this emergency button, so it will breaks my contact. And when I release this one, it will make again the contact. So how? We have to also change here. I go to my emergency start button. In the simulation, I will go to a normally switch. Okay. So when I press on this one, now when I simulated it, so you can see here, my emergency button. Here, my contactor is energized. When I press this button, so now if I press again this button, it will not work because I have to release my emergency button. So basically emergency button we don't use is a push button. We call it a press and release button. Yep. Now we have test our simulation. We can test our relay also. For example, it's our relay and then it's also have to reset it. Okay. Now this is our first PLC ladder logic program for our start and stop motor, or we call it DOL, direct online starter. Here you can also connect the PLC and then we can upload it to the PLC. We will do show in the next video this one. So now this is our complete program for this start and stop motor. Thank you for watching. See you in next video.